Sorry guys, I missed to log in. Are you able to hear me?
Yes, sir.
Sorry. So are you able to see my screen as well?
Yes, sir.
Yes, sir.
Very good. Okay. Okay. I forgot to save. I hit on discard. It was I wrote something, no? Okay. There's one problem with PowerPoint. I cannot press undo. Yeah. So what do? We consider two elements x1, x2 that belongs to the set A, where the function is mapped from A to B. Then we consider f of x1 is equal to f of x2, right? Then what should happen? You will solve for the relation between x1 and x2. If x1 is equal to x2, what will you get? It's a 1-1 function. If x1 is not equal to x2, then it is a many-to-one function. Many inputs are associated with same output, right? So the next question.
Sir, it
What
is
is-
not visible, sir.
My screen is not visible.
It's
Yes, sir.
small, sir.
Oh, it's smaller. Sorry. If you go again.
Yes, sir.
Yes, sir.
Yes, means now you're able to see it bigger.
Sir.
Okay. What about this scenario? Is it small?
Yes, sir.
Yes, sir.
Technology issues, Ra. Please
Now
forgive
it is
me.
like this.
No, now it will be, but I want big screen. Now is it big?
Yes, sir.
Yes, sir.
Okay, sir.
Yeah. For onto function, what is it we need to do? So for onto function, codomain should be equal to range. Means all the elements in the codomain set should have a pre-image associated. But what are the steps to be proven? What are the steps we follow? Yeah, tell me. Very good. Step number 1 is you will write y is equal to f of x. Then what will you do? Step 2 is write x in terms of y. You do this, write x in terms of y. Then what will you do? Then you will go and look at the function. F is mapped from A to B, right? For example, if I take this question itself, we know that y is equal to 2x because f of x is equal to 2x. Then what will you write x as? X will be equal to y by 2. This is step number 2. Then what should I look at? F is mapped from n to n, right? So this is the point. I'm assuming everyone is clear from yesterday's class, but I'm repeating it one more time. Just have a look at it. So what are we supposed to do? When you write x in terms of y, the domain and the codomain will get swapped. So when you write y is equal to f of x, this is domain and this is codomain. When you write x is equal to g of y, this will become the domain and this will become the codomain, right? Now what are we supposed to do? You need to plug in these values. In the place of y, you will plug in the values from the domain set. When you plug in the value of a natural number, what is expected? When you plug in a natural number is expected back. If that fails, so if it succeeds, it's a onto function. If it fails, it's not an onto function. Okay. So are you able to understand what I'm trying to say? Right. I think we did this problem yesterday. Right. So the same question, it will change with respect to something else. What is it? The function f is 1, 1. Sorry, not this one. Yeah. So prove that the function f is mapped from R to R given by f of x is equal to 2x is 1, 1 and onto. In the previous case, it would have been only 1, 1, but it would have not been onto. Here it is. Why? What are the steps again? For my satisfaction, tell me y is equal to 2x, step number 1, x is equal to y by 2, step number 2. Then what are we supposed to look at? Go to the function, the definition of function, look for the domain and the codomain. Now, who is the domain? For x is equal to y by 2. The right side one, this is the domain. When you substitute this value, what is expected? A real number is expected. Right? Having said this, shall we start with the remaining problems?
Yes, sir.
Now see. This one we didn't do, no? Now see. I want everybody to participate. Listen to this. Show that the function map from natural number set to a natural number set given by f of 1 is equal to f of 2 is equal to 1. Let's stop with that. What is the meaning of it? What is the meaning of it? If you have to visualize it, what do I have? I have a natural number set here. I have another natural number set on the other side, right? So I have the number starting from 1, 2, 3, so on till infinity. Here also I have the number starting from 1, 2, 3, so on till infinity, right? So what is the meaning of f of 1 is equal to 1? F of 1, the number 1 from here is associated with this according to the relation f. Then what is the meaning of f of 2 is equal to 1? 2 is also related to 1. Right? Now what happens here? It's failing to be 1, 1. So it's not a 1, 1 function. That itself helps us. Right? But we need not we should not stop it with here because these are the absolute values. Try to understand. What do you mean by absolute values? We know what is the value of y. Means if you plot it on a graph sheet, you know what is the value of y at x is equal to 1 and x is equal to 2. Meaning, if I plot the same thing on the graph sheet, right, what I'm going to get is, observe. This is 1, 0. This is 2, 0. 3, 4, keeps on going like this. When I substitute x is equal to 1, what is this function generating? When I put x is equal to 1, what is the function generating? 1. Meaning, this point is going to be, this is 0, 1. So this point is going to be 1, 1. Makes sense? What about the next point? When I put x is equal to 2, what is the value of y corresponding to it? 2, y value is 1. So what will I get here? I hope this is clear. But what is happening after 3? So what is happening after 2? F of x is equal to x minus 1. They didn't give us the absolute values. They gave the definition of function. Means they say you plug in the different values of x, it will change according to this relation x minus 1. Meaning, if I start substituting 3, what will I get? So I'll get 3, 2. If I substitute 4, what will I get? So like this, it keeps on going, but you're not supposed to join them. Listen to this carefully. You're not supposed to join them by. Why is it not continuous? It is natural number to natural number. Had the question been from real number to real number, you could have joined them. You're able to understand what I'm trying to say? See, this is the reason why I told you this chapter is important for you to understand continuity and differentiability. The 5th chapter. You would have learned this last year in the name of limits and differentiation. The same thing is changed as continuity and differentiability of whom? Of a function. Unless you have a clear understanding of these, you will not be able to solve them. Is it clear? So let's try to do it in this way. Right? This is not a continuous function. Can I speak in that language also? You're able to understand what do I mean by continuous, right? They are just discrete points. Right? Now, when x greater than so. So they are saying, prove that this is an onto function. How? What is the step number 1? Should I take this into consideration? Not necessary. Right? F of x, instead of f of x, I'll write it as y. So y is equal to, simple. What is the next step? X is equal to y plus 1. Where should my eyes go now? Look at the definition of the domain and the codomain. So f is mapped from natural number to natural number. Now this is the domain. So for every natural number you substitute in the place of y, are you getting back a natural number? Are you? Right. Starting from where? So you can substitute from 1 also. So when you substitute 1 here, what will you get? You will get 2. Right. When you substitute 2, 3. So like this, it keeps on going. So you will write it like this: for every n that belongs to the codomain set, what will you say? There exists a natural number that belongs to the domain set, which are, you're right. What is it? You call pre-image, no? Correct. Be confident. There exists a pre-image. You're right. There exists. You can either say there exists a pre-image from which set? From the natural number set that belongs to the domain. Right. Everything is the same. Are you able to understand? Tell me. Which one? F of x is equal. In that case, you will substitute it again. But you need not write that always. I'll teach you while we discuss inverse. Because that is the same method to prove that the function is onto. This is the method used to find the range. There is a method used to prove the inverse also. Okay, at that point you will understand. There I'll use that f of x is equal. This chapter is theory. I have no other option. You have to bear with me. There is nothing I can do interesting in this. I'm able to see some sleepy faces. Ilya? Right? Shall we proceed?
Yes, sir.
Listen. Show that the function f map from R to R defined as f of x is equal to x square is neither 1, 1 nor onto. So let's break the page into two parts. Right? For it to be proven as 1, 1, what are we supposed to do? Consider x1 comma x2 that belongs to whom? R.
R.
So f of x1 should be equal to, what is f of x1? Means I need to substitute x1 here. I'll get x1 square is equal to x2 square, which implies x1 is equal to, it is plus or minus x2. Hence, it's not a 1, 1 function. This I think we did it yesterday, right? What about an onto function? What about an onto function? Same logic, nothing. Y is equal to x square. So x will be equal to, actually it will be plus or minus square root of y. Right? It's plus or minus square root of y. So f is a function map from R to, now what should I do? Yes. Meaning, so y has this, right? In the codomain set, you have negative real numbers also. When you substitute a negative real number, you will not get a real number, you will get an imaginary number. Right? So for all negative real numbers from which set? From the
Real.
From the codomain set. There are no pre-images in the which set? Obviously, the domain set. Am I clear with this? Right?
Yes, sir.
So this is how it works. But one thing you should not get confused is, don't get confused between this plus or minus y and the one which is there inside the square. They both are different. Are you able to understand? Right? See, as I told you, once you are done with this, no, I'll explain it graphically also. Here, my you're not writing. அது ஹெல்ப் பண்ணல இதை நோட் பண்ணி பிகாஸ் ஃபர்கெட் டு சென்ட் த ஷீட் டவுட் வந்து என்ன பண்ணுவேன் வீடியோ காப்பியா இட்ஸ் a waste of time நோட் பண்ணி clear Hari Raghav clear yeah so I want you to tell me one thing Hari the previous class I told you there is a graphical way of testing a 1-1 function what is it I told some test what do we do how do you draw that straight line check your notes how do you draw it I gave a name also to it you remember Aditya can you tell me check your notes we call it as is there
Horizontal line.
we call something as horizontal line test so if you draw a line parallel to x-axis what is it supposed to do for it to be a 1-1 function the line should not cut the graph more than 1 point right so for that what I'm going to do is f of x is equal to x square is there no what is the shape of it what kind of a parabola it's an upward parabola because the coefficient of x square is positive so this is an upward parabola to this if I draw a line parallel to the x-axis it is cutting the graph at more than 1 point hence it's not onto grade it's a many to one function right what about onto function this itself is telling you see where is the graph confined to listen to this carefully see till now we use these steps no there is a simpler way to tell whether this is an onto or not once you draw the graph look at the place where the graph is confined to to which quadrants is it confined to the first and the second quadrant in the first and the second quadrant concentrate on the y axis in the first and the second quadrant what is the nature of y sign is it positive or negative both are positive am I clear with that point so it is positive meaning the graph is confined only to positive real numbers but what do we have in the codomain set we have real numbers means this side there is no pre-image existing it had the question been r2 r plus then it would have been an onto function am I clear with that so a small change will make the same function an onto or not depending on how you define the domain and the codomain so that is why as I told you most people miss this I want you all to concentrate on this right shall I proceed so are you able to understand the graphical representation for 1-1 and onto yes shall I proceed
Yes, sir.
I think they have given no they also gave okay they took some random value and wrote it now let's take this so there is a function that is defined from a natural number set to a natural number set okay f of x is equal to x plus 1 when if x is odd f of x is equal to x minus 1 if x is even meaning when you take the natural number set see listen when I take the natural number set the elements start with 1 2 3 so on till infinity similarly here the elements will be confined from 1 2 3 so on till infinity so when I take x what do you mean by if x is odd meaning this x is coming from this set the first set not the second set x comes from the first set y comes from the second set so if I take an odd number right if I take x is equal to 1 out of these two which function should I use so I should use f of x is equal to x plus 1 meaning I should put 1 here what will I get f of 1 will be equal to 2 what is the meaning of it when you take the input to be an odd number you are getting an even number because odd number plus 1 is going to be an even number makes sense similarly when I take 3 what function should I take same x plus 1 so what will be the value of f of 3 4 means 3 is mapped to 4 Right. Now, what about this number 2? When I take x is equal to Tejas, what will happen? What is that I need to consider? So I need to consider x minus 1. When I put this value, when I plug in this value, f of 2 will give me a 1, meaning this 2 is mapped to 1. 4 is mapped to, sorry, I can't undo, adjust it. So 4 is mapped to 3. Are you able to visualize what I'm trying to say? So if you take in this case, is it going to be a 1-1 function? It will be, because each input is associated to unique output. Again, when you substitute 1, you will never get 2 or 3. Each input is confined only to one output. Hence, it's a 1-1 function. It is 1-1. Actually, they told show that. Now, what about onto? Is it? So, for onto, what I'll do is, I'll take y is equal to x plus 1. Then x will be equal to y minus 1. So, f is a function mapped from n to n. So, it clearly says in this scenario, I'm not bothered about even or odd. When I substitute a natural number here, am I getting a natural number? Then what about y is equal to x minus 1? X will be equal to y plus 1. So, f is a function mapped from n to n. So, when I substitute a natural number here, I'm getting a natural. Hence, it's a onto function also. Is that point clear? So, tell me one thing. When you plot these two values, these two graphs, sorry. When you plot these two functions on a graph sheet, will you get a continuous function or a discontinuous function? You will get a discontinuous one, obviously, because it's mapped from n to n. So you'll get dots, right? So please make a note of this. No, actually, see, I have to correct this. But are you allowed to substitute 1 here? Why? Because x minus 1 is defined only for even numbers. So when you substitute the even number here, right, x minus 1 is going to be even. When you substitute an even number here, what are you getting actually? You're getting an odd number. So in the place of y, you will only substitute odd numbers. Oh, you're talking about this one, no? Now y minus 1, what are you supposed to substitute? You're supposed to substitute y as even. Why? Because when x is odd, you're substituting, no? What is the value of y that is getting generated? It's odd number, no? So this odd number, if you add a 1, it's an even number. So in this place, you will keep plugging in even numbers. So the first number that you will substitute in the place of y minus 1 is 2. You will not substitute 1. Clear, right? You finished it, huh? No doubts. Inverse pari. Inverse trigonometry. Read about inverse. Finished. Shall I proceed? So show that an onto function. They have already told that this function is onto. Show that this onto function is also 1-1. So how will you do this? Very simple. I have a set A, the set A, the set B. You can define it in whatever way you want. This is 1, 2, 3. This is 1, 2, 3. So for the function defined from A to B to be 1-1, what should happen? Each element, every element from set A should be associated to a unique element in set. When that is happening, for instance, if I take 1 is mapped to 1, then 2 is mapped to 2 and 3 is mapped to 3. Meaning, if 1 is mapped to 1, since they have already told, okay, sorry, I'm sorry. This is what is supposed to happen. But what is that they already told? They told it is an onto function. So if it has to be an onto function, what should happen? every element in the codomain should have a pre-image. For example, had I taken it like this, then what will happen? It won't be an onto function, but they already mentioned it's an onto function, right? So for this function to be onto, one thing that you're able to observe, I want you to observe a pattern here. What is it? What is the important thing you're able to observe from this? No, f of x1, that is something I drew. That's not given in the question. I told 1 is mapped to 1. Maybe 1 is mapped to 2 also. Can you slightly correct it? No, she's right actually. It is rare. The codomain idhila solriya? Okay, idhila illa. Okay. Now I have proved that 3 is mapped to 3. This is what is supposed to happen. Means all the elements here are exhausted. They have a pre-image. But what you're almost there. They start up. It's number of elements. So you're right actually. You're trying to say codomain is equal to domain because the numbers are same. But if you look at the number of elements, the number of elements in the domain set and the number of elements in the codomain set are equal. And if it is 1 to 1, it will always be onto also. Means it will always be biject. That's a very, very, very important point to be noted. If the number of elements in set A is equal to the number of elements in set B, if they say it is onto, then by default it is supposed to be 1, 1 also. If this is told, see, maybe they can ask you in an assertion reason. If want to function is given, then 1, 1 by default is accepted. Yes. Right? Shall I proceed?
Yes, sir. Same logic. What will you say? Same set, but the question is reverse 1, 2, 3, and you have 1, 2, 3. This is set A, this is set B. Am I right? So what are they saying? The function is meaning each element is associated with a unique output. See, for example, if I randomly draw it like, right, then what is it happening? Each element is associated with a unique element because they have already told it is 1, 1. But what is the other thing that is getting satisfied? Codomain is equal to range. So that is one way of answering, or how will you write it? See, in this chapter, no, understanding the concept is okay. But how will you present it in the exam? How will you write it? You can either say codomain is equal to range, or the other way is n of A is equal to n of B is our logic. That is something we are remembering here. Every element in the codomain set is having a pre-image associated. That's a common language. You can use it everywhere. Are you able to understand? Yes. So shall we proceed? Yes, sir.
I think example problems are done. Right. So look at the first problem. Tell me how we are supposed to do. In this question, you are able to see something in the domain and codomain. What is that they have put? You're able to see some special symbol. They have put an asterisk at the bottom. What is the meaning of it? They have given it. No? You take all the non-zero numbers. Okay. So meaning, what is the function given? What is the function given? R star to R star. Okay. Where f, this is the function. This is how f and y are related. F of x is equal to 1 by x. Where clearly one thing you can say. x is not equal to 0 and x is positive also. That's what the meaning is, right? R star is a set of all non-zero real numbers. This is result true if the R star is replaced by natural number with codomain being the same as R star. Meaning the second part of the question they're asking, if it was like this, does it still hold good is what they're asking. We'll come to that later. Oh, they told non-zero. Oh, sorry, sir. Okay. So x is not 0. That's it. I'm sorry. Yeah, except 0, all the values you can pick. I thought non-zero positive number. Sorry. So that is obvious. Right. See, I have a question. If this was not given in the question also, will you be able to find it? Denominator cannot be 0. Because what kind of a function is this? These are all the minor points we need to concentrate on. F of x is equal to 1 by x. If I ask you to categorize this as a function and tell me what is the name you will give to this, it's a rational function. Why? It's a polynomial by polynomial. Is 1 a polynomial? 9th standard. Recollect. Is 1 a polynomial? No. Theriyadu. Good answer. Yes, it is a polynomial. It's called as a constant polynomial. Because 1 you can write it as 1 into x power 0. It's a constant polynomial, right? So polynomial divided by what kind of a polynomial is this? It's a linear polynomial. So what should happen? What does the definition of a rational function tell you? Q of x should not be equal to 0. In this case, what is Q of x? X, no. X should not be equal to 0. So even if they didn't give this to you, you are supposed to find it. Purida, right? Now tell me, f of x is equal to 1 by x. Is this a 1-1 function? Simple, no? What are the steps we follow? x1 comma x2 belongs to R. Okay. So 1 by x1 will be equal to, which implies x1 is equal to x2. x1 would have not been equal to x2 when the value of x would have been 0. That is not possible because the domain itself doesn't have that value. So the other way of writing it is real number minus 0. You will see some notations like this also. I think you asked me yesterday, no? The R minus 7 by 5. Minus 7 by 5. Meaning of this is, from the real number set, you remove the element 0 alone. This is another way of writing. Am I clear with this? Okay. But can someone tell me how does the graph for this look like? Science student should know this, right? Thermodynamics. It's called a rectangular hyperbola. Okay, if you don't know, listen to this. You look something like this. This is how the graph will look. It's called as a rectangular hyperbola. For this, if you try to do the horizontal line test, is it passing or? It will clear it. And you see, x equal to 0, it is in the downward direction, it is going to minus infinity, means this graph will never touch the y-axis. This part will never touch the y-axis. It's going to plus infinity or minus infinity. This another thing you can remember. Okay, so have this in your mind. What is the name of this? It's called rectangular hyperbola. Okay. Next. What about, so I think we proved the 1-1 function. What about an onto function? What about onto function? The same number of steps, no. Y is equal to 1 by x. What are we supposed to do? Rearrange. X will be equal to 1 by y. So what are you allowed to substitute? Look at the functions, domain and the codomain. For every non-zero real number that you substitute, you get a non-zero real number. Means for every element that belongs to the codomain set, there is a pre-image. That's it. Makes sense? Right. So is the graph also helping you to understand whether it is onto or not? Let me see. X can never be 0. Y can also never be 0. So from the domain and the codomain set, 0 is removed. So are you getting all the real numbers? You are getting positive real numbers of y. you're getting the negative real numbers of y. All the real numbers are covered except 0. Hence, it's an onto function. Okay. This is another way. Slowly understand it. Okay. This is not used for CBSE, but if you can understand this, you can master continuity and differential. Okay. So they asked something else. So first finish this. Tell me the answer for the second one. It's not 1-1. Think. You are getting confused between onto and on. Did they say that every 1-1 function is supposed to be onto? Why are you even looking at codomain? What does 1-1 speak about? If you give one input, are you getting a unique output? Are you getting it? So is it 1-1 or not? Breathe. Okay. Well. It's not an onto function. Let others also come. I want to discuss this. So they asked something else, no? Second part of the question. Is this function still going to hold good for being a 1-1 and an onto function if the domain set is changed? So what was there here? Non-zero real numbers. Now it is changed to natural numbers, means all positive integers. Right? When you take the natural number set, is it going to be 1-1? Think, no, don't get confused between 1-1 and onto. Your mind should work independently. 1-1 says that for every input that you give, the output should be unique. Means, where does the set start from? When you substitute 1, the output is 1. When you substitute 2, the output is half. When you substitute 3, the output is 1/3. Like this, for every natural number that you substitute, because what is the function? 1/x? No. If I put n is equal to 1, f of 1 is 1, f of 2 is half, f of 3 is 1/3, f of 4, 1/4. All are real numbers. So you see the number will never get repeated. So every input has a unique output. It's a 1-1 function. But what about onto function? So for onto function, what are we supposed to do? X is equal to 1/y. So now how is the function changing? F is mapped from n to. So if I take a real number and substitute it here, for example, tell me a real number which you substitute will make you fail to get a natural number. If you substitute 3/2 here, for example, if y is equal to 3/2, I am taking from this set. I put it here. What will I get x as? I'll get 2/3, which is not a natural number. Hence, it's not an onto function. Okay. Clear with this? Yep. No, in first case it is on. First case it is on to, second case it is. Okay. 1-1 புரிஞ்சதா? He confused it between 1-1 and on. I think that's what you did, no? You spoke about the codomain. So it's a 1-1 function in both the cases. It's not onto in the second case. Okay. I think next problem is easy. Something from natural number to natural number. I hope everyone is clear with this, right?
Yes, sir.
Yeah. Shall I proceed? There's a solution. Right, you can have a look at it later. Second, check, I told you, they'll ask you like this also. Check the injectivity and the surjectivity of the following functions. Tell me. So going forward, you should do it in 2 steps, right? So for the first one, f is mapped from n to n. F of x is x square, right? So x1 comma x2 belongs to which set? Natural number set. What is f of x1? Sorry, f of x1 is equal to f of x2. So x1 square will be equal to x1 is equal to, but it is natural number only. No? It's a 1-1 function because you're taking only the natural, you don't take the minus into consideration. Why? Because the domain is natural numbers, no? So in this case, you don't write it as x1 is equal to plus or minus x2. Rather, you will write it as x1 is equal to x2. Meaning, okay. Here, if you plot it on a graph sheet, right, how will you get? Will you get a continuous graph? Wherever natural number to natural number, obviously you will not have a continuous graph. You will only have dots, right? For example, if the question was like this, f is mapped from r plus to r plus, just for you to understand what I'm trying to say. And f is mapped from r to r, like something over here. So you will draw this graph, no? This is the graph you're supposed to draw for this case. Whereas when they say r plus to r plus, no, it is only one side that you will. Because r minus is ignored. Think of what is happening. F is mapped from n to n. So you don't take the minus into consideration. X1 will be equal to x2. Hence, it is a 1-1 function. Okay, it is a 1-1 function. Then what about onto? Y is equal to x square. Right, then what will happen to x? X is equal to plus or minus square root of y. Okay, so in the place of y, what are you supposed to plug in? Natural number. And what is expected? Natural number. But is there a case where you substitute a value of y which will not give you a natural number? 2 itself will not give you, it's an irrational number. So there are certain elements in the codomain set which do not have a pre-image associated in the domain set. So what kind of function is this? It's a 1-1. It is 1-1, but not onto. Yes. 1-1 or onto. Yes. So injectivity is another name for 1-1. Surjective is on. Now, see, if you look at the first 3 questions, right, all the 3 are same functions, but what has changed? The domain and the codomain set. So tell me what will happen in the second case. Function is mapped from z to z. F of x is equal to x square. So is it a 1-1 function? It will not be a 1-1 function because you will have this step. Till this step it is common. But what will you get? You will get x1 is equal to plus or minus x2 because integers can be negative also. Hence, it's not a 1-1 function. But then what about onto? Obviously, not onto, because when you talk about integers, you can substitute negative values also here. Negative value is obviously not going to give you an integer. Integer is also a subset of real numbers. Third one, not? Okay, why? Again, you will get the same thing. X1 is equal to plus or minus x2. What about onto? I think we have already proven in the example problem. No? it is not onto, because you will get the same step. X is equal to plus or minus root y. In this y, what are you supposed to substitute? This real number. For every real number, will you get a real number output? No. Why? Because, for example, you substitute -2 here, you are not going to get a real number, you will get a complex number. Right? An imaginary, yeah. Imaginary or a complex, whatever it is. It's a combination of both. Am I clear?
Yes, sir.
You try for this x cube. You just try it. Yeah. Clear enough? So can you tell me what is the answer for fourth one? Is it 1, 1? F is a function mapped from natural numbers to natural number. F of x is equal to x cube. Right. So what is the meaning? How will you check the injectivity? Pranav, can you tell me? So first you will take x1, comma x2. Where do they come from? In this question, they come from the natural number set. So you are considering two natural numbers. Then what are you supposed to assume? F of x1 is equal to f of x2. This is an assumption. In this, what will you have? What will you get? Very good. X1 cube is equal to x2 cube. When you take the cube root on both the sides, unlike the square root and the fourth root, you will not get plus or minus. You will only get either plus or either minus. So from this, what can you conclude? X1 is equal to x2. Hence, it's a 1, 1 function. Then what about onto? For onto, what will you do? Can you tell me? Yeah. So first you'll write y is equal to x cube. Then what will you take on both the sides? Y power in the root. Which root? Cube root. Okay. So x will be equal to y power 1 by 3. So now you need to look at the domain and the codomain. F is mapped from R to R. Sorry, N to N. Natural number to natural number. So what are you supposed to substitute here? Natural number. Is there any, you are able to prove that there is a natural number whose cube root will not give you a natural number? We have. What is it? For example, you substitute 2. Cube root of 2 is not going to be a natural number. All right. Hence, it's not onto. It is 1, 1, but not onto. What about the next case? What about the next case? F is mapped from Z to Z, given by f of x is equal to x cube. It's a 1, 1 function. Because you will again see the same step for cube root. X1 cube is equal to x2 cube, you will get x1 is equal to x2. Right? That is right. It's a 1, 1 function. Y power 1 by 3, what will happen? In the place of y, you need to substitute integer, and the output expected is a integer. You will not get no. Then you can do. So what is the next problem? We'll just do one last problem and wind it up. So 6, 5, okay. And we'll wind up. See, this greatest integer function I need to recollect. I mean, I need to remind you how this function works. It's also called a step of x. It looks like step on a graph sheet. Okay, there is a very important function because we'll discuss about this in 5th chapter also. So we'll see them in the next class. So tomorrow I'll do only, let's say, 4 to 5 problems. After that, I'll go to the inverse. So that in the weekend, you can sit and practice this chapter and come with doubts on Monday. By Monday, I want to wind up this chapter. Okay. And one more thing. If you see the app, right, there is another I'm not sure how many of you went and saw the videos. In the videos, you have videos of this year, and I've also added pre-recorded videos for this chapter. See, those who are not able to, like, there is a confusion or something. I've broken down into chunks. Almost, I think 27 topics are there. I don't remember how many are there. But if you, whichever topic you want to see what is a transitive relation, you can go there. What is an equivalence relation? It is there. Like 5 to 10 minutes, I've completed the video. You can make use of that, right? If possible, go through inverse also, and so that you will understand things better. Is the point clear? So anything else? It's clear, no? I'll see you all tomorrow.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you.